So it's been a week. My machine has been performing absolutely horribly, and that's for good reason. The reason is I've been running a automated AI red team using Promptfoo against the GPT OSS 20 billion model. I want to say $20 billion model on my machine to see where it's vulnerable. And this is a little bit different from some other attacks that I've been simulating against the chatbot for Maze Loop called Marty that I've been talking about recently. But this attack, these automated attacks that I've been running using Promptfoo, have taken almost a full week to run. I have learned a lot in that time. During this time, I realized my machine probably wasn't up to the task of using a 20 billion model. And I've gone and bought a new graphics card, which has been shipped and is on the way. And so I'm really excited to get that tested. It's not high end, it's kind of middle of the road in terms of graphics cards, but it is much more optimized for AI. It's got a lot more video RAM, which is something that has been lacking with the current one that I've got. The graphics card I've got at the moment, the GPU, it's got about 6 gig of RAM. The new one has 16 gig of RAM. So huge difference in GPU power, and I can't wait to get it going. But what we've got here is the results of the Promptfoo test on the local model. And what was hard to see was, as I've been waiting the past week, that there were a few failures. And this is what I understand to be outside the attack success rate, the ASR metric. And what we're really dealing with is some errors in the ability for it to effectively scan and to detect some vulnerabilities within the model itself. So what we've got, 950 successes, 263 failures, 152 errors, with a pass rate of 69.6%. So the failures refer to the attack success rate. The errors are something completely different. What I'm really looking forward to is going through the logs, and I was doing this during the testing, but I wasn't satisfied with what I was getting. And I don't know whether that was because it buffers a lot of the errors in memory, or it buffers a lot of the progress in memory. But there are 3 log files from Olama that you can look at. There's a server log and there's a couple of other ones. Plain text, nothing too exciting. But there's also some database logs too. So I started looking through the SQLite browser, using the SQLite browser tool to go through those logs to expand the database to see what I could get. At this point in time, I couldn't get anything worthwhile. What I was seeing was just some really high-level schema stuff. What I'm hoping to get is to get some real catching the suspect at the keyboard type stuff. What I really want to find is, what are people using the local model for? So taking this to a forensic investigation model, if people are deploying local models on their work PC, or if they're doing this and there's a law enforcement issue, what I'm fascinated about and trying to get into the research of is, how can we prove from a digital forensics viewpoint, what is this local model being used for? So at the moment, there's a lot of excitement, I guess you could call it, about using a local model. And the difference between using a cloud model to a local model is that it's a lot harder for law enforcement or for the cloud providers to see what you're doing. In this case, if you're running a local model, then obviously the cloud providers have no idea what you're doing. It's all stored locally, it's processed there, and there's no external connection. And I've tested this because I put my machine in flight mode, disabled all the network cards, tested, does this model still work? Yes, it does. So, excluding whether it does some kind of phone home, right? And I have a suspicion that maybe some of the other models that exist out there may do that. All that aside, the paranoia putting to the side for a second, if the consensus is that we can run a local model and then we can use it to do bad things, ask it questions that we wouldn't want to ask of a cloud model, because it's illegal, immoral, whatever, does that mean that people can get away with murder, so to speak, right? What I want to prove is how we can extract those queries in the same way as looking up internet history. How can we look through these logs and get information about what is being done? My background in digital forensics and incident response in a corporate landscape, this is very attractive. There will be a lot of shadow AI. There's the places I've worked, they've mandated that you can use AI for certain functions. You can only, some places have rules about you can only use their AI. You can only use Google Gemini, for example. And they're very open with the use of Google Gemini, but you've got to use it and it's sanctioned in that way. The question is, what is being logged? Who has access to what is being searched for and what is being looked up? And does that become the intellectual property of the company? All random questions that I'm thinking about this morning. So with that in mind, now that the test is finally complete, I can commence my forensic analysis of the database, the logs, see what we can find. But overall, on this Friday morning, I'm just very excited that the test is finally complete and I can take a look at the results, see what the attack success ratio is for this 20 billion model and see where the vulnerabilities lie. Obviously, prompt injection will still be a massive one. But now that the test is finished, there's a whole lot of tests that I want to run against the OWASP top 10 for LLMs and start seeing what we can find in regards to that. So stick around. There'll be more of these coming out as I dive into the research of what I found and come along on the journey with me to see what we can find together. Looking forward to it, and hopefully we find some really cool, juicy artifacts. Okay, that's it for now. Bye.